So we just covered some questions on the OneNote from a previous exam, just did that, so you might want to go and have a look. So I didn't record it because didn't want to have your names popping up over there from OneNote, but we can always go through that at a different time. So what we're now going to do is have a look at our, going back and remembering how to do row operations, and we can apply this to when we have two lines intersecting, and instead of having three things here, you would just have the two, X and Y, and Z, right? And then we've got this with the planes. So we figure if we can just do it with the planes once, you can apply all of that knowledge back to when you've just got lines. Okay, so we're just going to refresh our memory of how to actually do row reduction. Then we're going to apply it to interpret what it means in specific spots. Obviously, you can solve this in your graphics calculator in the equation solver. But as you might have recalled from last year, I'm hoping you might have done these. Okay. Right. So you have then some unknowns that come your way. So we want to be able to do it by hand using numbers. Then we're going to have unknowns. And so if we can work it with numbers, surely we can work with A's and M's and all that sort of stuff. All right, so let's get that. Just a little bit of memory from year 11. Just because they've given the equations to you in that order doesn't mean you have to keep them in that order. So if, let's imagine that one was given to you first, it's going to be easier for you if your first row has a 1 there. So you can reorder the order of the equations to suit your needs. Okay, I mean, I could have put row 3 up there, but it doesn't really bother me. You must write down your row operations. I also encourage students to even show their little calculations to the side, not just for the marker, but also for you to help you when you find an error. Now, sometimes, like when we're going to get rid of just the ones, you 12 speckies, you might not need to do that. So we've written the first one, we write this again, we keep our first. Who can remember what is the aim of our game? We're trying to get a 0 here and a 0 here for our first step, and then preferably also get a 0 there. Reduced row echelon form. That's what that is called. So sometimes they'll just say use row operations to solve. Sometimes they'll say put it in reduced row echelon form. We know all of that stuff. Okay, so in order to get a 0 here, what are we going to do? Not yet. This one here. Okay, so yep, and it's up to you. I want this to be a 2 and subtract. You can either go 2 row 1, take row 2, or row 2, take 2 row 1. Sometimes I don't care. I don't mind if I deal with negatives. I'd like to go top to bottom. I mix it up. In this case, clearly, it's going to end up being 6, take 1. So I will write 2 row 1 minus row 2. When I went through this, I can remember my teacher, we had to call this one row 1, row 2, row 3. Then we changed it. It had to be row 2 dashed equals. And you changed it again. It was row 2 dash dash. It's like, oh, good Lord. And you were doing calculus at the same time with all the dashes. Like, craze. Anyway, so 2, 6 minus 2, 30. 2, 1, 1, 7. So 0, 5 minus 3, 23. This is also not the time to be speedy, because if you stuff up anywhere here, you miss a minus. It is a pain in the neck to go back and solve it. What do they say in tech? Measure twice, cut once. In maths, check twice, write once, maybe, I don't know. Okay, how do we get a 0 down here? Yep, so we're going to go row 1, take row 3. And once you've changed row 2, you can't use it in this step to fiddle with row 3, right? Don't do that. The next set we can, but at the moment, no. So, yep. I'm going to be bold in this case and not do it to the side because I'm not timesing anything. So 1 take 1, I'm pretty confident is 0. 3 take 1. 4 minus 1 take 2. 15 take 0. Oh, thank God for you, 0. Okay, now you're basically at the point where you're just doing good old year 10 elimination. Okay, so this is a 5, this is a 4. What are you going to have to do to make them disappear? Yep, so the question was, can you use row 1? You cannot, because then you'll have 1 take 0. So 1's out now, right? Now we're fiddling with this, and we go through, if you remember elimination in year 10, what's the number that 5 and 4 both go into? 20. I mean, you can, there is nothing wrong with you actually getting rid of the Z, but it's just nice to go 0, 0, 0. It's just nice. Okay, so we're going to multiply row 2 by 4 and row 3 by 5. Okay, so, yep, everybody happy? Yes, I multiplied something wrong. So now we're subtracting to make the 20s disappear. 0 take 0, 0, 20 take 20, 0, minus 12 take 5 is minus 17. Oops. Now, this is actually an oops. Why? What happens if I'm checking my work and I go back? Is it a 0? Is it a 6? So do make sure it's little things like that. What's 92 take 75? Oh, isn't that nice? 17. Okay. If you were really finicky, obviously, if instead of you doing 4 row 2 take 5 row 1, you could have gone 5 row 3 take row 2 and it would have been 17. But, you know, it doesn't matter because you will then, this is your Z column, so therefore minus, leave a gap, Ange, therefore minus 17 Z equals 17, so Z is 1. Sub back in to get your Y value, so we've now got minus 1. 5Y, just seeing if you were paying attention. Sure, it was a mistake. 5Z equals 23. I don't normally even bother writing that in. I just go straight into, that would be 5Y plus 3 equals 23. Get rid of the plus 3, take 3. Get rid of that. That's 20 divided by 5 is 4. Yeah. And then sub back into the very top one and you get your X. So we've got X plus 3Y. Y is we've just found is 4. So plus 12 minus Z. So minus Z, that becomes plus 1 is 15. 12, 13, so X is 2. Not that bad, right? As I said, you want to now just go back and practice these with numbers. Frustrating, yes, because we know that our calculator could just do it in a heartbeat. One of the things, though, as you are going through, is we want to consider our last row. The maths thing. So some of this is summarized on that little bit I showed you on OneNote, but while you're doing these, this is still going to come up, right? So if we have the bottom row and we end up with 0, 0, 0, something, right? I could put like an A or a B there, but what we're saying is this value here does not equal 0. What happens in this situation? What's going on? We're saying 0Z equals 5. And what do we think about that? Right, we can say this is impossible. Not possible, right? Because 0 times anything has to be 0. So there we say, therefore, no solution. Okay, in 2D stuff, that would mean we've got parallel lines happening, so they do not meet. When we're looking at planes, we'll consider that bit momentarily. So that's one system. What if the last row was? What if the last row was that? Right, so this one is okay, yeah? Because once again, you've got 5z equals 0, and this is valid because z can have a solution being 0. How many times do you think I've been told no solution for this one? Quite a couple. So do make sure, if you're ever in doubt, just do exactly what we've done just here and go, well, will it work, will it not work? Okay? Hello? I just coming to that, not finished yet, stealing my thunder. That's right. So the question was, what happens if it's all zeros? So 0, 0, 0, 0. Anybody? We've covered no solution, unique solution. I should have finished that off and said unique solution. Pardon? Right, which means, so they just said coincident. Right, so this could be infinitely many solutions. And when we've got this happening, right, what we would have to then do is go let z equal t. And then you will be going, okay, we'll go y. Now, we would have done this in year 11, yeah? Not realize, yes, no, yay, nay. Yes, okay, don't remember, that's okay. So when we just did these randomly in year 11, and we write down that we're getting infinitely many solutions, you go, oh, we're just rewriting it. And we go, yep, all disappears. We let z be t. We pop it back in, so now we've got minus 3y plus 3t equals 1, and you go along your merry way and you go, yeah, infinitely many solutions. What this actually means, anyone? What is this? X equals 7/3, y equals t, z, t. This represents a, yeah, it's a line in parametric form. So when we're going later on to have a look, it can mean that we've actually got planes and they intersect at a common line. I know, crazy but true. So they are going to be a couple. So when we do 6j, you're going to get maybe one or two where you do have to write those infinitely many solutions. So look out for it. It's not a bad thing if all the lines disappear. And I would also imagine if it's a good question, which I think it is, there'll also be one where it's no solution. So have a go, get stuck in, all good. Hello, forgot to record. So did number 1. Hopefully, or A, hopefully that makes sense. Coming to B, we took bets on B, C or D, which one is going to be no solution, infinitely many solutions and unique. So, what one is this? Done my little working out to the side here because I forgot to leave space. Hopefully you can follow all my instructions. I don't know, depending on how you were taught with your elimination back in the day, whether you always want to add or you always want to take your rows, I don't care. I just look and go, well, I'm going to add now because one's positive, one's negative. Add them, they cancel out. But we notice zeros are happening all over the shop. I've rewritten this again, and we were just saying you didn't have to make it 0, 0, 1, 0, but since I was rewriting for the third row, I might as well do it. And so times this by 11, subtract from here, you end up with 0, 0, 0, 0, which means we have what type of solution? Right, and so in this case we have infinitely many solutions, as you said, Josh, on a line. So infinitely, and therefore we are going to start by saying let z equal, we won't let z equal t, or why not? Because we've got nothing here, we'll get stuck there, and we've got this line here which is actually saying, yep, 1 times z equals 0. So in this case, great one to go with. We're going to go, no, it's not z equal t, it's going to be y equals t, because from this row right here, we can actually find out that 1 times z, 1 times z equals 0, therefore z is 0. And therefore we have x being minus 2t plus 5 times 0, which is 0, equals 1. So therefore x is 1 plus 2t. And those are my 3 solutions. And okay, let's just write it all out because I like to be precise. So that will be x equals 1 plus 2t. y equals t and z equals 0.
That's the line for the 2 planes.
Well, at the moment, yes, it's just infinitely many solutions. But yes, when we then interpret it, this will be the line where, now you have to go back and you have to suss, because we've just got one line here. So is it that we've got all 3 planes intersect at one line? What else could happen if it's only one line? I need my bits of paper now. Sorry, I'm putting the microphone down. But it could be, so here's my 3 planes, de trois, yes? So we could have all 3 like this. Sorry, microphone. In fact, I'll just turn you off. Wonderful weekend playing with your rowops, right? Because you will finish, oh, come on. You will finish C and D. You can finish some of that before you leave today, one hopes. You are then going on, we've discussed a little bit of this before, have a look-see. We can discuss more when you come back, but we are now just going on and you're going to, I guess, interpret. You're quite capable of reading. Interpret what that means. It starts off a bit funky, so I don't worry about how many dimensions. I don't know. Oh, maybe. You have a look, have a read. When we've only got 2 planes, well, what's going to happen? Then you will not have a unique solution, will you? When you've just got 2 planes. They're either going to be parallel, and so no solution. They could be coincident, so infinitely many, or what's the third option, just when you have 2 planes? One line intersect, right? They meet at a line, because that's already saying your bottom row is 0, 0, 0, because there's not a third one. Does that make sense? So I think we can do that. I should have from memory. So look at C part. That's not very nice. Look at C part 3. Here, what do you notice? So I'd like to think you're not, see, they just said they're multiples of each other. So I'm hoping you wouldn't even bother writing that down, that you recognise right from the get-go. Huzzah? So look, see how your time goes going through. What did our schedule say? Got vector geometry to do. Nothing too onerous. But there's an awful lot of review sets to go back and just pull all of this together. We've also got the revision guide questions, and pull up some old exam ones as well to have a look at. So 2 weeks today, we have a test. We can do this, but please don't put it off and do the, I'll just focus on my methods roller coaster. Or, I got a physics test coming up. Plan your time and make sure that you devote it equally, although more spec.